All right. Well, in this video, we're going to actually try doing some of this stuff, trying to figure out how we can get this to work. This software that we're going to be talking about today is the software AMOS. So we're going to be opening up AMOS on our computer and seeing if we can't get this data read in and do a couple of confirmatory factor analysis models to investigate. We'll be trying to echo the confirmatory factor analyses that we showed in the lecture notes, just the pictures. Now we're going to get to make them and run all the statistics for them. So let's go on and open up Amos on your computer. Now, I feel like I have to give you a fair warning, and there's a lot of people who are going to be grumpy if I say this, but to me, Amos is a pretty clunky system. It's never really been my favorite. There's a lot of things that I really like about it. But there's a lot of things that are just really clunky about it. Um, so I say this as we're getting started in it because I don't want you to find the immense frustration that I share to be a surprise. I want you to be aware this is something that I experienced too. I think this is something others experience too. So it's something to just be aware of ahead of time. After you get used to it, though, hopefully it'll be less of a fight to get it to do what you're looking for. So I'm just gonna open the screen. I'm gonna zoom in a little bit here by scrolling my mouse wheel and get ready. So I'm gonna start by making the one factor 6 item model, and I should probably start by frankly just loading up my data set. That's probably a good place to start. So I'm gonna go over here on the left hand side and click Select Data Files. And I'm going to go to File Name and find the file on my computer. In this case, my file's on my desktop. So select the data file that I'm going to be working with. In this case, the Holsinger Swingford. It's a slightly edited version, but it's one we'll use for our class. And then I'll click OK. And now the data is in. Again, it doesn't actually tell you or show you anything, but now I can access the information from Amos. Okay, so let's go on and start drawing stuff. So I'm going to come up here to this button here, Draw Latent Variable, and I can either click to create a circle or I can click and drag to create a circle of a little bit bigger size or a little bit less size. I'm going to erase by clicking the X button and Xing out of these. So I can do either of those depending on what I'm interested in. I'm going to make mine a little bit bigger because I'm going to have lots of indicators associated with it. And if I'm using this top right button to create my latent variable, I can click, after I've made my circle, I can click on it to add indicators to it. 3, 4, 5, 6. I'm going to have 6 indicators for a single latent variable, as we talked about as the first model we tested in the lecture notes. Now for me, having these face upwards is a little bit awkward. So instead, I'm going to have them face downward. How I can do that in Amos is I can click on this little circle button, which rotates the way that these items are phrased or are drawn in Amos. All right, so now I'm ready to go on and add in variables. So I'm going to go to this button here, list the variables in the data set, and click it to list out the different variables in the data set. I'm going to open this window up a little bit, and now I'm going to add the variables that I'm going to study in this particular case. So I'm going to be pulling these 6 variables eventually: visual perception, cubes, flags, paragraph composition, sentence composition, and word meaning, and I'll just go on and click and drag them in. So I click, drag, pull it in, 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 and click, drag, pull it in. Now, these are getting a little bit noisy here after I've pulled these in. I could resize the different squares, but that's going to be too big for my model. Um, one thing that I can do, though, is, oh, well, I just did something here. I can go to View up in the top left, Interface Properties, and then go over to MISC, Miscellaneous, and then click on Display Variable Labels, which is currently checked. So that gives me the label from SPSS, but if I just want the name from SPSS, I can uncheck the label box, and that makes it a little bit shorter and easier to see for me at least. With these other ones that are left, I can go over to this button, change the shape of objects, and go to the ones that I want to make bigger. I can click on a corner and drag it to be a little bit bigger so that it fits the object. And then last but not least, to tidy this up, because now these are running into each other a little bit, I can click the fire truck to move them around. And then I'll move their errors too. Not pretty, but prettier, maybe. All right. Now, we really haven't discussed this in our lecture, but what does this 1 mean in this line here? Well, ultimately, what the 1 does is it sets the scale of the variable. And I think that there's a lot of ways to describe this, but ultimately, the thing to think about is that this underlying variable is a conglomeration of several different variables. In this case, we're hypothesizing a conglomeration of 6, or is reflected in 6. But it doesn't itself have any scale or meaning. So this is one of the reasons we do standardized estimates. We discussed standardized regression in our lecture, because standardizing gives this a scale. It gives it a scale in terms of standard deviations. But we don't really know, like, let's say we have multiple positively or negatively phrased items. So let's say paragraph composition is I can compose a paragraph well, whereas a reverse phrase sentence composition is I cannot compose a sentence well. One of these reversed coded items, is the main factor going to follow the positively phrased or the negatively phrased item? And it purely depends on where we put this 1. So the 1 is an indicator variable, and it says I want the scale of this underlying variable to follow that of the indicator. Now, while this may not be particularly appropriate for or particularly necessary for confirmatory factor analysis, because I don't really care about the raw numbers, I'm just looking for problems in the measurement model. When we get into structural equation modeling, where we are really looking to determine what the relationships between variables are, if they're positive, if they're negative, etc., this is very, very important to specify correctly. So we want to make sure that we're setting the indicator variable to something that makes sense. In this case, word meaning, okay, fine. I don't see that as a bad or a good thing. I don't really know much about this example, so I'll leave it at word meaning its default value for now. We mentioned that we can calculate model identifiability, how many variances and covariances we're estimating. So in this particular case, I can see how many different options I have in my or how many different quote unquote data points I have in my variance covariance matrix. So I can do P 1, 2, 3, 4, 5, 6. That's my P, the number of observed variables, times P plus 1, so 6 times 7. I think that's what, 42, hopefully? And then I divide by 2, so that gives me 21. I have 21 unique pieces of information I can estimate. From here, I'm estimating 1, 2, 3, 4, 5, 6 error variances, 1, 2, 3, 4, 5 paths, and 1 variable variance. So in this particular case, I have 1, 2, 3, 4, 5, 6, 12 pieces of information that I'm going to be estimating using my 21 pieces of information. So I do have an over-identified model. That is, I do have enough pieces of data to actually estimate this model. You'll note that to have enough pieces of information to estimate the model, you'll typically need at least 3, 1, 2, 3, because with 3, you'll have 6 pieces of information, be estimating 1, 2, 3, 4, 5, and then 6 the variance. That at least makes sure that your model is at least identified. All right, so let's see what statistics that we want to calculate. Well, first of all, let's go on a name variable. So I'm going to call this variable. I can double click my circle to go into name it. I'll call the variable name factor1. Now I could go in and double click each of these error terms to name them errors, but AMOS has a nice little plug-in that says name unobserved variables, and it automatically names these for me, error 1, 2, 3, 4, 5, 6, so I don't have to worry about that. I'll just click on the plugins, name unobserved variables. So I can either name them manually or I can name them via the menu. To determine what statistics I run, I go to the Analysis Properties box located here, or button, click on Analysis Properties. I can pick my method by which I'm analyzing my results. So I'm going to do maximum likelihood. I'm just going to leave it there. I'm going to ignore a lot of this. There's different things that you can do here if you want to. I'm not going to worry about any of those. I'm just going to focus on the things that we've talked about in class. Again, keep it pretty simple, pretty basic, and go to output. In output, the thing that we're really going to want here that we discussed in class is standardized estimates. Other common things you could do are squared multiple correlations, modification indices, residual moments. I might do modification indices just so that we can look at them and glance at them. And then I'm going to click X to save those as my statistics that I'm going to plan on calculating. All right. So I'm going to go on and save my model, which is required to run it. I'll call this our CFA video model. Click Save. And then I'm going to click the Run button, which is right above the Save icon. Oh, and it looks like I have a space in my variable name. Excuse me, so I'll do factor_1. Thank you. Click Save, and then rerun again. Now you'll see some estimates on here. I'll note that the default estimates that AMOS provides are unstandardized estimates. I can change them to standardized estimates by clicking on standardized estimates here. And I can look at my item loadings. All of these item loadings, paragraph composition, sentence composition, word meaning, all load very strongly on here. Flags, cubes, and visual perception all load very weakly on here. So it kind of seems like this seems to be one of our, this seems to be the grouping it's loading on. Not surprising, we made this our indicated variable word meaning. Let's look at overall item or overall model fit though, which is typically what we look at before we look at item fit. So I'm going to click on my results right next to the save button, view text. I can go to model fit. I have a little plus button where I can look at everything individually, or if I just click model fit, it shows me all of the tables on top of each other. So the C-min represents the chi-squared. So I can see the chi-squared, the degrees of freedom, the p-value. Again, statistical significance means our model is far away from what was actually observed. And then I see a plethora of different fit statistics. Ones we've talked about in class. Well, we talked about GFI, NFI. We said those are not good, but other ones we talked about in class, IFI, TLI, CFI we presented. I can see that these are rather poor. I could copy and paste these and make a table. Let's scroll down. So CFI, none of them are above the 0.9 threshold we typically have. Let's see what else we have in here. RMSEA, our threshold was 0.808, and it had to be below that. So this is not below our threshold. This isn't particularly good. AIC, we didn't have an interpretation for this, but we can note this so that we can compare this later. AIC. So yeah, this model doesn't look like it's doing a very good job here at capturing our data. One thing that's missing here, though, is the SRMR, and this is a pretty important one. AMOS doesn't calculate SRMR by default, so let's go and figure out how to calculate this SRMR. What I'm going to do is I'm going to go to Plugins, and I'm going to click Standardized RMR, and this is going to load a blank box. And I'm just going to keep the blank box there. And what's going to happen is when I go over and click Calculate Estimates, it's going to fill in that blank box with the standardized RMR, the SRMR. So the SRMR for this case is 0.1144, and that is located in this blank box that I have to pull up. Note that if I pull it up after running, just like I just did, it's not filled in. So I have to pull it up and leave it open when I click the run button, or else this won't be calculated. Other interesting things in this, there's a lot of things you can click on here. Model fit's the big one. The other big one you can do is estimates. This has the regression weights. These are the unstandardized. Then the standardized weights of, in this case, we only have loadings under the factor. We have the variances for the factor and all of the error terms. Big things you can do here, you can click down and then you can pull up just the table of standardized regression weights, just the table of unstandardized regression weights. I will mention that the unstandardized regression weights have p-values, so I can see all of these statistically significantly load on that factor. The standardized regression weights, again, show me how large those loadings are. Again, the broad interpretation of this model right now is that the model doesn't seem to particularly fit well. And so I'm going to go on and move to our second model, which involved adding a second factor. So to add a second factor, what I'm going to need to do is go to the model editing view. Among other things, I'm going to need to add another circle, which is currently grayed out, and delete some of the paths, which is currently grayed out. And that's because AMOS is in a model viewing view. To get to a model editing view, I go up at the top part of this menu here and click on the left-hand side. This moves me from model viewing the results to model editing. So the right side's model viewing the results, left side is model editing. In my model editing, I'll go on and X out the paths between visual perception, cubes, and flags, and move this factor on over to this side, sentence composition, paragraph composition, word meaning. Then I'm going to go on and add a new factor using this circle here, draw unobserved variables. And I'll add a new factor right above these items over here on the left. I'll draw some paths from this factor to visual perception, from this factor to cubes, from this factor to flags, as we have in our drawing that we looked at in our lecture notes. I might name this factor on the right-hand side now factor 2 because we have two of them. This one on the left I'll name factor 1. Again, double-click into there to do that. You'll note that these paths are looking pretty yucky. I might center this, but then if I want to straighten up the paths, I can go to this little magic wand here, and that'll straighten up how my paths look on everything that I click on. So I can click on the squares, that'll straighten up where the arrows land on the squares. I can click on the circle, I'll straighten up where the arrows land on the circle. And hopefully just make this whole thing look a little bit prettier than it was. It's pretty easy to not be pretty in AMOS, sadly. All right, well, unclick my magic arrow. One thing I'm missing over here in factor 1 is an indicator variable. So I'll go on and just select visual perception as my indicator variable. I do this by double-clicking on the arrow and then going to parameters. Now, if I ever had an indicator variable I wanted to change, in parameters, this regression weight is going to be 1, and I would just delete that. And then go to the new indicator variable path that I wanted to make, double click on it, just like I did now, go to parameters and set the regression weight to be 1, and this adds the 1 there. Again, if I wanted to change it from word meaning to paragraph composition, we'll just do this for fun. Double click on word meaning, the path, double click on the arrow. The regression weight is 1. I'll delete that. That removes the loading, the indicator variable's word meaning. I'll go to paragraph composition, double click this, and assign the regression weight to be 1 for paragraph composition. Fantastic. From here, I can choose to correlate the factors if I'm ready for it, but for Model 2, we had uncorrelated factors. That was part of what Model 2 was and what separated it from Model 3. So in this particular case, what I'm going to do is run and interpret. So I'll go on and save. I'll keep the same analyses that I was running before, and I'll go on and click Calculate Estimates. AMOS gives me a warning. It says, these are currently uncorrelated. Are you sure you want to do that? And I'll say, yeah, I'm sure I want to do that. I can see that these loadings on factor 2 look good. The loadings on factor 1, some of them look better than others. But again, I'm going to ignore that for now and just go to model fit. So I'll click on my view text results, click on model fit, and I see my chi-squared is still statistically significant, not a huge surprise. The CFI looks good, the IFI looks good, but the TFI looks bad. The RMSEA looks bad, and the SRMR, oh darn, I forgot to do the SRMR. I gotta go plug in SRMR and then rerun the analyses to get the SRMR. Here's the SRMR. I have 0.154, so this looks pretty bad too. So overall, this model looks bad. I can look at the AIC in model fit, and comparing with the last one, I see this AIC is better than the last one. So it doesn't have the results for the last one. I'd have had to write those down. But in this case, the AIC looks better than the last one, and that's a good thing. That means this model is performing better. It's just still not very good. So you can be better than other models and still not be very good. I can look up the estimates and see the regression weights with the statistical tests and the standardized regression weights. All the loadings are statistically significant that we tested, but again, the model doesn't look very good. Some of these loadings look a little low. Cubes looks a little low. Visual perception looks fine, and flags look fine. All the ones in the factor 2 look fine, but the model fit doesn't seem very good. So what I'm going to do now, after I've decided model fit fits better than model 1, so relative fit's good, but is still not very good, is I'm going to go and fit model 3, which involves going back to the model editing view and adding a double-sided arrow between factor 1 and factor 2. I'll do my little magic wand to maybe make it a little prettier. So this double-sided arrow between factor 1 and factor 2, which is going to tell me between factor 1 and factor 2, or it's going to allow a relationship to be between factor 1 and factor 2 of the underlying variables. And so we'll just go on, save this current path. I'm going to open up the SRMR because I remembered this time. And then I'm going to hit run so that I can see how the model fit looks for this new model. Going to model fit. Well, the chi-squared is looking better. Degrees of freedom, you have chi-squared over degrees of freedom here. It's about 3. So it's your ratio. CFI looks good. Oh, CFI actually looks good. IFI looks good. TLI looks good. So these things are good. Okay. RMSEA, not great. The low part of the confidence interval looks like this very well could be good, but the high part isn't, and the middle of that confidence interval isn't. That's the point estimate here. So RMSEA I'll call borderline. It's only 0.02 away from the traditional cutoff, so I'm not going to call it bad, but it's everything else looks good, so I'll call RMSEA good too. SRMR looked good wherever SRMR is. SRMR looks good here. So I'm going to call this good model fit. This seems to be fitting well objectively. Looking at the ISE, this also seems to fit better than the previous models, so relative fit also looks good, which is a good thing. From here, I could go to estimates to look at which of the factor loadings are statistically significant. I see all the factor loadings are statistically significant. I can interpret the standardized regression weights. Again, cubes looks a little low. Now flags is a little lower. But overall model fit looks good, and as we talked about in the lecture slides, this is one that I'd probably, I don't know too much about this test, but as long as cubes makes theoretical sense and flag makes theoretical sense to be included in factor 1, I'd probably keep them in there. All right, well, this has been a demonstration of how I can fit and run and interpret a confirmatory factor analysis model using the AMOS software. And this closes out our lecture set on confirmatory factor analysis.